Okay, guys, so today we are looking at section 9.7. So our learning goals today are that we want to be able to verify identities, simplify trigonometric expressions, and solve trig equations. We're actually going to get to this tomorrow, but we're going to do these first two today. So here are the reciprocal identities, and these you will have to have memorized. If you compare this paper to the orange sheet that I gave you, so the orange sheet is what you will be given for our next quiz. So if you look for these reciprocal identities, you will see that they are not listed on here. Okay, so these you will have to have memorized, but I think you probably already know these. So these have to be memorized. Does everyone know that if I gave you the cosecant to be 2, then you automatically know the sine would have to be the reciprocal of that, right? We all know those. Okay, then we also have the tangent and cotangent identities. So we talked about earlier how the tangent of theta on the unit circle is y over x. Well, what is y on the unit circle? Is it sine or cosine? Sine. So the tangent of theta can also be described as sine theta over cosine theta, since on the unit circle, the sine of any angle is equivalent to the y value. So these you really already know, but we may not have really looked at them in this way. So cotangent is the reciprocal of sine. So what's cotangent theta? X over y. And so therefore, cosine is going to have to be x, which is the same as the cosine of theta on the unit circle, over y, which is the same as the sine of theta on the unit circle. Sometimes people have trouble with these. They kind of get them mixed up. I just always think cosine, or cotangent rather, has cosine on the top. Just kind of helps you to remember it. Okay. These are the Pythagorean identities. So the Pythagorean identities come from this fact. If this is a unit circle here, and this is x and this is y, using the Pythagorean theorem, what would have to be true for this right here? Right. Now, what is x the same as on the unit circle? Cosine. So cosine squared of an angle plus sine squared of an angle. So here's really the cosine, and that value squared plus this value squared is always going to be equal to that hypotenuse squared, which is 1. Okay, so that's where this really comes from. Sine is the same thing as y squared. Cosine is the same thing as x squared equals 1. That's really what that is. Okay. Now, the next one we come to is this one right here. And this one isn't quite as intuitive. So let's say we already know this one. What would I divide this by so that, actually, let's look down here. What can I divide this by so that I could get secant? What's the reciprocal of secant? Cosine, right? So I could then, what's another name for cosine? Is it x or y? X. So if I divide this by x squared, I have to divide this by x squared, and I have to divide this by x squared. So what is y over x the same as from up above? Tangent. So here's y over x. So tangent of theta squared plus, then what's x squared over x squared? 1, right? And then what's 1 over x? Secant squared. So that's where this comes from, okay? Now, we've started with this, and we've divided by x squared. What's the other variable that I could divide this by? Y squared. So let's see what happens if I divide by y squared. What's y squared over y squared? 1. What's x over y? Cotangent squared. And then what's 1 over y? Cosecant squared. Okay? Now, guys, on these Pythagorean identities, this really means you would find the sine of theta, get that answer, and then square it. Okay, that's what that means. All right, cofunction identities. These are things you probably have already noticed. For example, have you guys noticed how the sine of 30 degrees is the same as the cosine of what? 60 degrees. So if we are given the sine of pi over 2 minus theta, that's going to be the same thing as cosine theta, because what's pi over 2 in degrees? 90. So that's saying that if I'm trying to do the sine of 90 minus 60, that's going to be the same thing as just cosine of 60. So these are some other ones we'll be applying. And then finally these. Let's look at where these come from, you guys. The sine of negative theta. What does negative theta mean? Instead of going up, I'm going to do what? Go down. So like, let's say I'm trying to find the sine of negative 30. Isn't that the same thing as negative the sine of positive 30? What's the sine of negative 30 going to be? Negative 1/2, right? And then what's the sine of positive 30? 1/2, but then you would have to put a negative to keep them equivalent, right? Okay, let's look at this. The cosine of negative theta equals the cosine of theta. Can anyone explain why that is true? Let's use 60 degrees, guys. What is the cosine of 60 degrees? 1/2. What is the cosine of negative 60 degrees? So isn't it true that the cosine of negative 60 is the same as the cosine of 60? Okay, so that just has to do with our quadrants and where everything's positive or negative. All right, let's do this one. You guys don't even need to be writing all this down. I'm just kind of showing you why these work. The tangent of negative 45. Let's use 45. What's the tangent of negative 45 degrees? Negative 1. Is it the same thing as what's the tangent of positive 45 degrees? But then you would have to make it a negative to make them equivalent. Okay, that's all we're saying here. All right, let's do some problems here. We've got the cosine of pi over 2 minus pi over 3. What I could do is get a common denominator, subtract these, and then evaluate. But if I just look at this right here, the cosine of pi over 2 minus pi over 3 will be the same thing as the sine of what? And what is the sine of pi over 3? Good. So that was faster, wasn't it, than trying to actually figure out what this is? You see what I mean? I would have to rewrite this as 3 pi over 6 minus, and this would be written as 2 pi over 6. So what's 3 pi over 6 minus 2 pi over 6? And then you would still have to do the cosine of pi over 6, and the cosine of pi over 6 is radical 3 over 2. So this was faster, okay? That's what these identities do. They allow us to figure out things faster. Okay, so the sine of negative 45, sine of negative 45 is going to be negative the sine of positive 45 degrees. Do you know what positive 45 degrees is? And so this is going to be negative radical 2 over 2. Is that a true statement? In that fourth quadrant, is sine negative? Yeah. Okay. All right, let's do this one. It is, but let's take a look at it. We're going to do it the long way first, though. This means we have to do the sine of 30 degrees and then square it. What is the sine of 30 degrees, you guys? 1/2. Now we're going to have to square it. Plus, what's the cosine of 30 degrees? And then we have to square it. So what's 1/2 squared? What's radical 3 over 2 squared? What's 1/4 plus 3/4? 1. How could I have used my identities? Can you see this identity right here? So is the angle the same in both of those? Are we using the same theta? So therefore, at the very beginning, I think Ryan didn't say 1 at the very beginning because he noticed that this was this Pythagorean identity. Okay? All right, let's keep going now. So remember those proofs from geometry that you probably didn't really care for a whole lot? Well, that's what we're going to be doing right here. But they're not traditional proofs in that we don't have to really give a reason, okay? The reason they are proofs, though, is because I'm trying to prove that this side is equal to this side. So what I'm going to do is I'm going to draw a line here, and I'm not going to go across that, because what I'm trying to do is make sure that this side is the same thing as this side. I'm proving it. So when we are verifying or simplifying, we're going to look for Pythagorean identities. That's one thing we can look for. Another method that's helpful is to write every factor in terms of sine or cosine. That helps sometimes. We might want to get a common denominator to combine fractions. But you should only work on one side of the expression when verifying, also known as proving. All right. When I see 1 plus cotangent squared x, I'm automatically thinking of a Pythagorean identity. Rather than flipping back, let's look at this paper right here. Or you can flip back if you want. What am I told that 1 plus cotangent squared of an angle is equal to? Cosecant squared of that angle, right? So this is going to stay the same, secant squared x. But this denominator, 1 plus cotangent squared, is going to be the same thing as cosecant squared. Now I have to keep the angle the same as what I'm given. So this is going to be cosecant squared x. Now, I'm trying to prove that this is the same thing as tangent squared. Right now, I can't really see it, but watch what I'm going to do. I'm going to think of this as secant squared x times 1 over cosecant squared x. What would be another name for secant squared x in terms of cosine? Now, that's one of these that's not going to be on the orange paper that you have to know. So this is the other thing we have to memorize. All right, guys, so what is secant squared theta going to be the same as? 1 over cosine. So this secant squared right here can be replaced with 1 over cosine squared x. What can 1 over cosecant get replaced with? Well, if I know cosecant is 1 over sine, what's 1 over cosecant going to be? Sine. So I can replace this, but it's not going to be just sine. If it's 1 over cosecant squared, what's it going to be then? Sine squared x. All right. So now I have 1 times sine squared on the top. So what's 1 times sine squared? This is over 1. Sine squared, right? Over what? So let's now look back at our paper here. Hopefully you remember this, but if not, look back. What do we have again? What is sine over cosine the same as? Tangent. So therefore, what is sine squared over cosine squared the same as? Tangent squared. And now I am finished. Victory right there. That doesn't say not equals to. It should say equals to. It's just my dotted line. So that's how I know I'm finished, is when I can make that statement and show that this side right here is equal to the other side. Guys, another hint, always work with the more complicated side. Do you see how this has more terms to it than this did? It's going to be easier to take a lot of terms down to something singular rather than something singular and spread it out. Okay? All right, guys, let's look at this next one. Which side are we going to work with, left or right? Left. All right. Is cosecant over cosine the same as anything? No, it's not. One of the methods that we can use is to write everything, every factor or term, in terms of sine or cosine. So right now, this is cosecant, so I might want to make it into what? If I move it to the bottom, what would it turn into? Sine. So what I can do then is I can rewrite this as 1 over sine x cosine x minus, I'm not doing anything with this. All right. So what might be a good thing to do now? Get a what? Common denominator. So what would I multiply this by? Yep, cosine x over cosine x. So the first one's going to just stay the same. First term is the same, but the second one's going to be minus cosine squared x over sine x cosine x. Now that I have a common denominator, I can put the numerator together. 1 minus cosine squared x is what I can call the top. Now, looking at our Pythagorean identities, what would 1 minus cosine squared be equal to? Sine squared. So I'm going to replace this 1 minus cosine squared with sine squared. Let me pause for just a minute here. A common mistake people make is that when they're back here, they think they can cancel this cosine out with this cosine, but this is terms. We can only cancel when we only have multiplication and not addition or subtraction. This is subtraction. I cannot cancel. But now this is all multiplication, so I can cancel. What would cancel out? What would I be left with? If I have sine times sine on the top and sine times cosine on the bottom, what's that going to turn into? And why is that good that it turned into sine over cosine? That is tangent. And that is victory right there. We did it. Okay? All right. Let's do a couple more because I know this is new and it might seem a little difficult to some of you when you're first starting. All right, let's look at this one. One of our methods is to write everything in terms of sine and cosine, but another method is just to distribute and rearrange things. See, once you've done these a couple of times, then you kind of can see some patterns. Why might it be a good thing to distribute this through? What? Yeah, that's one reason. So we don't forget to multiply by a -1. Why else, though? Can you think ahead and think what we're going to get if I distribute that through? I will. And why is it good to have sine squared plus a cosine squared? What's that the same thing as? So that's why I'm thinking ahead like, ooh, that's going to be good to just go ahead and distribute this negative. All right, so watch, guys. We're going to distribute this negative through. This doesn't change. This doesn't change. Minus tangent squared x. And then what? Plus cosine squared x. And I'm trying to get this to equal 2. Kind of took up a lot of room there. So now I can rearrange this however I want. It's addition and subtraction. So what I'm going to do is I'm going to put this over here. Sine squared x plus cosine squared x plus secant squared x minus tangent squared x. What is sine squared x plus cosine squared x? 1. All right, let's look at our paper. What do we hope secant squared x minus tangent squared x is? 1. That's what our hope is, and let's look. So if I have secant, oops, you can't see that. If I have secant squared of an angle minus tangent squared of an angle, will that be equal to 1? Yes. So therefore, this got replaced with a 1. This gets replaced with a 1. Do we have it? Yes, we do. As long as 1 plus 1 is 2, we've got it. So there we go. We proved it. We're done. You can do it. It's going to seem difficult the first day, and then the second day it's going to click, and you'll be like, ah, I can go all the way through this. Okay, guys, let's look at this one. I want to do, we're going to go through to number 6, and then we're going to stop, okay, for today, through number 6. Okay, this one, number 4. This is kind of tricky. We can do either side, whichever side you guys want, because one really isn't more simple than the other. Personally, I have a preference, and I'll see if you guys agree. What do you want to do, left or right? Really? I wanted to do left. The reason I want to do left is because I can just add or subtract, and I can make something go down to multiplication easier by getting a common denominator, rather than trying to make this go to subtraction or addition. Okay, so really the left side is going to be a little bit easier. So let's stick with the left, okay? I mean, we could do this, but it'll go faster this way. Anybody have an idea on what we should do here? What do you want to do with cosecant? Okay, so 1 over sine minus sine x. All right, what do you guys think now? Common denominator, because I'm trying to squeeze this. I'm trying to condense it. So if I'm getting a common denominator, I have to multiply this by sine x on top and by sine x on bottom. Let's zoom in here. So what am I now going to have? Well, I'm going to have 1 minus, what's sine x times sine x? Sine squared x, and I have a common denominator of sine x. We're kind of constantly looking at what we're trying to get. I don't think we have it quite yet. Would you know another name for 1 minus sine squared x? Good. You guys are getting the hang of these already. It's almost like you memorize these because you use them so often. So 1 minus sine squared is going to be cosine squared x. Now, this is good. The reason this is good is because this is cosine squared x. So what does cosine squared x mean? Cosine x times cosine x. And right now it's all over sine x, but I don't have to have it that way. I can put this sine x just under one of them, because wouldn't it be okay? Isn't it true that this would still be cosine squared over sine if I wrote it like this? Okay, so what's cosine x divided by 1? Cosine x. What's cosine over sine? Cotangent. Is that what we wanted? Yes, it is. There we go. Okay. Let's flip over. Now, I always like when it says to verify, because I know where I'm trying to go. It's You know what the answer is. You're just trying to prove that that is the answer. When it says this, though, simplify to a single expression, now you don't know what the answer is. And you've just got to get it down to one single trig value. Okay? It seems difficult, but it's really not, because these are typically just easier problems anyway. Okay, let's take it one step at a time. Tangent of negative theta. Look at your list. What's another name for tangent of negative theta? Negative tangent theta. So I already have this negative out in front. This is going to get replaced with negative tangent theta, and it's over secant theta. Well, I don't have this down to a single value yet. If I have a negative over a negative, what's that going to be? Positive. Okay. Now's where we want to switch everything in terms of sine and cosine. Okay. So I'm going to split this up. I'm going to think of this as tangent theta times 1 over secant theta. Always split it apart. It kind of goes against like what you would think to do, because we're trying to get this down to a single expression, but splitting it up is going to do that. What is another name for tangent? What over what in terms of sine and cosine? Sine over cosine. What is another name for 1 over secant? Cosine. Yay. Why do I say that? Right. And so all of this is the same thing as sine theta. Is that a single expression? Yes. So we know we're finished. Okay. So we don't know for sure what the answer should be, but the computation and everything in there is going to be a little simpler. All right, guys, this is our last one for today. The sine of pi over 2 minus x. Can you just remember without even looking at your paper what that is? Good. This is cosine x. And if this had been a theta, we would put cosine theta, but we have to match. So it's cosine theta. And over secant. Some of you may already know what this is. Right now we have two different trig expressions. We want a single trig expression. You guys know what to do? What do we do? What do I do with this? I split this, separate it. What's 1 over secant the same as? Cosine. What's cosine times cosine? And that's it. That's a single trig expression. All right, so how do you feel about this scale of 1 to 5? 3s and 4s. Okay, that's good enough for me. We're going to stop there. You guys have a worksheet. I want you to do 1 through 15 odd on it for today. And then tomorrow, I'm going to finish these notes and you will finish the worksheet in class. Okay?